Hello, good evening everyone. So I think we'll wait for a couple of minutes so that if anyone joins and thereafter we'll start the session. Good evening. Hello Priya, Priyamvada. I hope I'm audible. Hello. I think we'll start today's session. So am I audible everyone? Please if anyone may confirm. Okay, I think we'll start. So, good evening, everyone. Firstly, I'll introduce myself. This is Adyasha Sahoo, a PhD scholar from IIT Roorkee, and I'm pursuing my PhD in Power Systems Engineering in the Department of Electrical Engineering. So, I just would like if anyone may confirm, like unmute or say that if my voice is audible and presentation is visible, so that we'll start with the session. You may also type in the chat box if you're comfortable. Hello, hello. I think, is it audible now? I don't know why this person. Hello, is it audible now? Okay, okay, then I'll start. Thanks for confirming. So without any delay, I think we'll move forward. So, uh, so I'm Adyasha Sahu. I'm working as a PhD scholar in the Department of Electrical Engineering at IIT Roorkee, and my specialization is Power Systems Engineering. So I think all of you have. So am I not audible to? Okay, I can hear you, but is it okay now? Okay, is it fine now if I speak here without any microphone? Hello? Now it's fine, I think. Okay, I am extremely sorry for this technical issue. So, okay, okay, thank you. So, we'll start here. I am sorry, I think we have delayed by 15 minutes. So, just introduce myself briefly. I am Adyasha Sahoo and I am pursuing my PhD at IIT Roorkee in the Department of Electrical Engineering, and my specialization is in Power Systems Engineering. So I hope you all have registered for this course, NPTEL course, Smart Grid Basics to Advanced Technology. So for week 1, yes, Mr. NK Alangu, if you have any question. Do you have any query? Okay, I'll move on. So I hope you all have watched the video lectures for week 1. So what we'll be doing in this session is I'll first summarize the week's content for you all, and then my screen is visible, right? Okay, thank you. So I'll summarize the week's content for you, and then what we'll do is we will go for some question and answers related to that week's content, and then we'll move on to the doubts if you have any. So firstly is this topic is smart grid, which is consisting of two words. So we'll first understand what is a grid. So as you can see in this figure, this grid, it is majorly consisting of four domains or sectors, what we can say. First is the generation, where we all have the generating stations, followed by our transmission network consisting of various transmission lines, towers, transformers, and then we have the substation or step-down transformer at the distribution level, and at the end sector we have our consumers or customers. So we will look at briefly at each of these sectors. Firstly is the generating station. So here, as we know that the power or the energy can neither be created nor be destroyed, we can only transform it. So what we do at generating station is we convert other forms of energy, such in the form of like a heat energy for your coal power plants, or kinetic energy of water for hydro power plants. Then we have nuclear power plants where we harness the atomic energy of. I think I am the audio issue is resolved. I am audible right now. Can anyone please confirm? Okay, I will try to be louder. I don't know why this Bluetooth is not working. It was working. Maybe I'll try just once more. So, is my voice okay now, or is it gone? If anyone may please confirm.
Hello. So, shall we proceed? I think if it's okay now. Maybe someone please confirm. Is the quality okay now? Hello? Sunita, is it audible now? Okay, okay, I'll proceed then. Thanks for confirming. Thank you. So we were talking about generating stations where. So is it for all or is it only for Bhanu Prasad so that we may know who is at the wrong end? I'd like others to also give some feedback. Okay. I don't actually check, guys. Is this mic fine now? Is it this good? Hello? 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 Hello?
वो बाहर होना चाहिए ना,
हाँ
यही इशू है क्या? इसको पता अब देखो
नहीं, तो आप बोल रहे तो आ रहा मेरा क्यों नहीं?
हेलो हेलो
हेलो, आई वेलकम.
अब आ रहा है.
हेलो 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 हेलो, इससे आ रहा है. हेलो, कभी आ रहा है कभी नहीं आ रहा है. हेलो, गुड इवनिंग एवरीवन. हेलो, बीच में रुक रहा है शायद ना.
वो आएगा सर मेरे देख हो जाएगा
इसमें
Hello. Turn on your laptop. Hello. Good evening, everyone. Hello. I welcome you all. ये ठीक है, I think.
ये सही है सबसे.
I'll join, I think now.
ये वाले से
Hello. I am extremely sorry. Please, if someone may. Hello. I think I am audible now, and it's clear also. Okay, I am extremely sorry. I'm extremely sorry. We are delayed, so we'll just move on to the session. Okay. Okay, so I think we talked about the generating stations. Now we'll move to the part of transmission lines. So in the transmission, after we have generated the power, now we need to transmit this amount of power to the end users or the customers. So this is done by our transmission lines, which are ultra high voltage ACs, or right now we are even switching to high voltage DC lines due to their many advantages. So can anyone just tell me one, 2 points if why HVDC is better over ultra high voltage AC lines? Any idea? So basically what happens is the power losses in DC is very low because you must have heard about the phenomenon of skin effect in the AC conductors. So due to the absence of that, the resistance of our DC lines are much lower, leading to lower power losses. So for larger distances, these HVDC lines transmitting power are more efficient, we can say. Secondly, for DC, we know that they have zero frequency, implying that you must have heard about the phenomenon of electromagnetic interference, where due to the frequency or the magnetic field of these lines, they interfere with the neighboring telephone lines. So as the frequency is 0 here, so that interference or that disturbances are absent in the DC lines. Secondly, they can be connected asynchronously to the other systems. So that is the major advantage also in HVDC lines, for which some major DC line HVDC projects are going on in India and Europe worldwide. So after transmitting it to the, we say, let's say to customers, we have to step down this voltage, high voltages, to the customer levels, which for which we have the step down transformer at the substations. So at the substation also, we are now moving to a new era where we will be having grid automation, where all the monitoring of the system is automated now. We have SCADA and PLC systems. And after the substation transformer, we have three kinds of consumers with us. First is the sub-transmission level customers, which take directly power at higher voltages. So basically, these are big factories and big industries, manufacturing industries. And moving on next, we have primary level customers. These are also commercial customers, and at the very end, we have users like us. These are the secondary customers drawing power at 240 volt or 120 volt line to neutral, we can say. So we are the secondary customers who are utilizing this power. So moving on, we'll see the next. Okay, the next slide. We had the regulating authorities. We'll discuss about the regulating authorities for our Indian national grid. So at the top hierarchy, we have the Ministry of Power, who will pass all the bills or related to all the reforms which will take part in our energy sector. So that is headed by the Ministry of Power. Then we have the central transmission utility. So does anyone know what is the name or the company who acts as the transmission central transmission utility of our country. So actually, it is PGCIL or Power Grid Corporation India Limited, which takes care of the transmission of at the central level. So its role, it will provide open access to all the utility users who want to use the uh, transmission lines, and they have to pay some tariffs or charges that is decided centrally by jointly by in accordance with the Central Electricity Authority and Ministry of Power, and they will also act as a authority who will coordinate the coordinate those who want to use the transmission lines, like the maybe the regional load dispatch centers, maybe other state transmission utility owners. So they'll coordinate among themselves, and it is the judicial body who will take all the decisions regarding the use of these interstate transmission lines. And this is at the central level. For the state level, or for the intrastate level, we have the state transmission utilities. Then moving on, we have the authority, that is CEA, or Central Electricity Authority. So this governing body is responsible for all the acts, like the National Electricity Plan, according to which our system is running. So that was framed or formulated by this Central Electricity Authority, and its additional function is also they will survey the demand that is going to happen in, let's say, 10 to 20 years, and accordingly develop other hydro or power plants or other power plants to meet that anticipated amount of demand. Additionally, we will also see for the need of other infrastructures related to support this demand, such as deployment of transmission lines or transformers, whichever is required to meet that amount of load in the future. Then we have the CERC at the central level, the SCRC at the state level. So these they will regulate again. They will regulate the interstate transmissions, the tariffs that will be used for this interstate transmission, and they will grant the licenses to the those who want to go to use these transmission lines, and they are again a judicial body for the electricity sectors. Moving on, we have Grid Controller of India. Previously, it was known as POSOCO. So it is the National Load Dispatch Center, and is responsible for the we can say day ahead load dispatch problem of the country. So at whatever power that you're getting, so which generating station is going to cater which amount of load, that is decided in a day ahead basis, and the NLDC, National Load Dispatch Center, that is POSOCO, is the head in charge of this load dispatch problem. So these 5 to 6 bodies, they cover the regulating authorities of the electrical grid of India. Then let us see what are the features of this grid which are making it smart. Firstly, coming to the transmission sector, due to, as we have discussed, due to the deployment of these HVDC lines, what we are getting is we are getting transmitting powers over very long distances at a very cheaper rate. So one thing I'd also like to ask here, like if losses play such an important role in our sector, so why don't we have our generating stations close to the customer so that we don't even need to transform that power, and those losses can be overcome? I'd like to hear from you your views so that we can learn from each other. So, like I discussed, we are so much worried about these transmission losses and how to transmit power and have this huge infrastructure of lines and converters if we have HVDC. So why even to have that network? And why don't we have the customers or consumers close to the generating stations? That way we overcome all these issues. Okay, I'll let this question go and you may think of it in the coming week. So moving on, we'll have next feature of this smart grid is faster restoration of the system. So even though we are very concerned and very much we have planned everything, things may go wrong at any time. This is nothing is in our hands, and in those unfavorable situations, there may be completely failure of the grid, or sometimes will be partial failure. So what we need is we need to recover from this unfavorable states faster, so that we have lower impact to the consumers, and also the cost which will be involved, that also get reduced. So we need faster restoration in case of any partial or complete blackout of the system. Third, and the third is the reduced cost. So we want that the consumers which we have, they get reliable power at lower cost. So that is the third feature of our smart grid. Then forthcoming we have reduced peak demand. So this peak demand means over the day, as we know, the load is keeps on changing, and during certain period of time, the amount of demand that is over on the system, that we are unable to meet. So that is major issue, and that can be overcome when we have larger amount of renewables, so that they can take care of that peak demand for a certain situation, a certain time instant, and by that we can flatten this load curve over the 24 hours of time. So, and for this greater integration of renewables, we need to improve in our infrastructure. We need to have better control systems. We need to have better converters, and these all need we need also policies and reforms. That is the main one. We need standards for that. So that will only facilitate the integration of renewables to our grid. And all these things will lead to improved security or security of power to the consumers. So next, what you may have seen in the lectures is the components of our smart grid. So these components of smart grid can be divided into four main uh, sections. They are smart infrastructure, smart communication, smart management, and smart protection. So under smart infrastructure, what we have is two parts. What is first is smart energy system, and then smart information system. So for a smart energy system, we have our generation, transmission, and distribution. So how is the generation becoming a smarter energy system? We can say, will anyone like to share anything? So how this bulk generation is changing in the era of smart grid. So as we know previously, can anyone say previously what was the type of energy mix in the generation and what it is now? Like earlier, we were focused only on power from coal power plants, some nuclear stations, and some hydropower plants. But then, can anyone just share with me what led to this transition from these sources to the what is the current scenario now? So we know what the talk of the era is now for reduced carbon emissions. Every country wants to reduce their carbon footprint, and so is India. So, for that only, we are moving to a more clean and green energy system, and this can be done with the help of other naturally available resources, greener resources such as solar energy, wind energy, and sometimes geothermal energy. And we are also moving towards power drawn from tides or tidal energy. So, harnessing these green powers will lead to reduction of carbon emissions due to the coal-based thermal power plants. Similarly, coming to transmission, we know earlier when I just told you, so we are moving from AC transmission lines to high voltage DC transmission line for efficient and economic transmission of power from generation to the distribution systems. And additionally, these transmission lines, we are now equipping it with PMUs to monitor the health of our grid continuously. Coming to distribution system, so distribution system is actually the main role is playing, and its role has changed massively from, we can say, pre-smart grid era to post-smart grid era. So can anyone share any feature which has changed in the distribution system over this, let's say, past few years? Hello, yes, now it is two-way communication. Okay, that is one point. Good. And what are? So earlier, I think this distribution system was a passive load, right? All of us in the consumer side, we were always consuming power. Am I correct? So what is the change now, if you think in that way? If you come to the consumer side, so yes, you're welcome. One by one, we'll start with Bhanu. Yes, you may share your thoughts. Yes, what? Sorry, I couldn't get you. You can control the power flow from where to where. Like, yeah, that you can be in control way. But I want to say this power flow. It is always from distribution, from the, like, say, from generation, transmission to distribution level, then to the consumers. Or there is some shift in this power flow direction. Can the consumers now they are loads, right? Consumers, we are consuming energy. So at any point, can these loads they act as generations? Can they are now evolving to generations? Like, can they inject? In what scenario can we yeah, yeah, correct. So that is one answer. And okay, I'll get back to this. And Bhanu, what do you want to share about this changing role of distribution? Yes, very rightly said, both of you. So what is changing now? There's what is changing that we are now feeding energy back to the grid. So there is reverse power flow from the distribution to the transmission in the form of our installed distributed generator sources such as the solar PVs. So what will happen is the grid is not prepared for these kind of scenarios. It was always prepared for a unidirectional power flow from transmission to distribution. So these bidirectional power flows, and these are also not controlled. So do you control what amount of solar power you're injecting to the grid? It is not controlled as of now. So simply whenever there is excess of energy, you are feeding it to the grid. As a customer, you are not worried what impact you're having on the grid. But this is the major problem that this distribution system earlier it had a passive load. Passive means it was earlier acting only as a load drawing power. But what has happened now that it has started injecting power back to the transmission system. And what is happening that all these relays and these PMUs they were not like ready to face this kind of scenarios. So we need to like revisit the current practices in the form of let's say how we are operating the system, the protection systems. So everything now they have to again see how to control, monitor and protect the grid in the scenario of this power flows from the distribution to the transmission levels. Okay. And also, as you have rightly said, now we have smart control metering also, where we are able to see our consumptions at real time, what we are consuming, and we have all the data with us in more about real time situations. Then, this is the part of smart information systems, and then coming up to sensors and PMU. So, can anyone tell me about PMU? Any brief idea? Or I'll be happy to even hear the full form of PMU. Yeah, it's correct. So, do you know what this device is? Okay, grid stability we can't say, but basically it will capture, we can say, according to not only voltage, you can voltage profiles and the current profiles, and it will measure its phasor quantities. That is both its magnitude as well as angle. And what we'll do with this data is we'll monitor the health of the grid. And can anyone say what using this data from PMU, which study we can use to monitor the health of our grid? Like getting this data, let's say, okay, you have installed the PMUs. After that, what? How to utilize this data in what kind of studies? Yeah, it is in synchronization with the clock, but that is to extract the data. I'm talking about, let's say, you have the data of a PMU. So using this data, can you monitor the health of the grid? Can you say the whether the grid is in a stable or unstable condition? Okay, so what specific study you have to do? What is the name of that study that we do? So have you heard about state estimation? Okay, so state estimation, like we have different studies in power system, like power flow or load flow studies. Similarly, we have state estimation studies, where basically we use this PMUs are actually basically very costly devices. So we have this information of data not at all the buses, at some buses. So using this data at some buses, we do the state estimation of our grid, and we'll know the voltage magnitude and angle at each and every bus. And after that, looking at this value, we may make a decision that whether our grid is in a stable or unstable state. So that will come in the information management, where let's say, okay, your smart meter, we have sensors, and we have got huge data with us. So the information management will try to process this data. We'll try to read this data and make the use of it to know the health of our grid. So next, moving on, we have smart communication. So we have all this data and we have all these domains. So to communicate with them, we need to have communication between the domains, and that we do with the help of various wireless or wired technologies. And coming to smart management. So can anyone tell me what we do in this smart management section? What is our aim? Sensors, sure. So sensors, we have PMU is also a sensor, because what we are doing is you are getting at a bus, you have a PMU, and you are trying to sense whatever you want. Let's say you want to know the voltage phasors or the current phasors, or sometimes it may measure also frequency. So similarly, these sensors also, according to the placement of their and the use whichever you want to, they will get the state of the system, and from that, getting that data, you'll process it, you'll do some studies, and by that you'll get to know whether your grid is healthy or not. So I hope it's clear. Okay, so I was asking about, I think, a smart management. Yeah, so what does this component of smart grid aim to? So for this power system, our first and foremost aim is always to match the generation with the demand, so that the sum of energy that is being generated, that should be equal to the sum of load that is being served. So are you aware about this? Okay, so what will be the problem if the generation is not matching to the load? And that in the case when it is not matching, but what will be the problem? Let's say our generation is of 100 megawatt and we have a load of 120 megawatt. So what will happen if this 20 megawatt of energy is not, if load is not matched? Yeah, overloading, and that will in turn lead to what? Tripping of the circuit. Before that, why that circuit will trip? Voltage and any other, because this is active power, and active power is not directly, or we can say strongly related to voltage. It is some other quantity. Yeah, frequency, correct. Our active power is closely related to the frequency component. So any mismatch in the active power, that will reflect in the frequency of the grid. And whenever there is a dip or rise in the frequency, we have relays to protect our system, and then it will lead to tripping of the system. Okay, so the smart management, what it will try to do, it will try to make the generation equal to demand at each and every time instant, so that we can maintain the frequency of our grid. So what is the frequency of our grid? 50 hertz. And do you think that the frequency of this grid is exact 50 hertz at all instants, or is there any violations? Plus minus 5% we have, and within that we operate the grid. We try to operate the grid. That is the ideal condition. And again, the smart management, what it tries to do is reduce the emissions for our green grid, and then we also would like to increase the efficiency of our system, and we also would like to decrease the cost of the energy. So these are all the objectives you can say for smart management. Then coming to smart protection. So any idea about smart protection? So what are the components of our protection system? Okay, relays are okay. So relay, what they will do if they see a unfavorable situation? Okay, how the circuit will trip? Like which component will do that? Yeah. Okay, Ria, if you may unmute yourself if you are comfortable, and I'd like to hear from you. Good evening. Yeah. So relay is again a sensor. It does not have the power to trip the circuit. It will send it back to the circuit breaker. And what will happen if the circuit breaker does not trip? Let's say relay has sent the signal to the circuit breaker, but the circuit breaker fails to operate. Under that condition, yeah, so that will have some time coordination for backup protection. And if the circuit is not tripping, so that in that case, that backup relay will again send the signal to the circuit breaker. So what was the, though, as I said earlier, these relays, these circuit breakers, and they were all uh, habituated with the former practice, which was unidirectional of power flow. And when this DERs, distributed energy resources, they are coming to the distribution system, so they are injecting back the power to the grid. So sometimes it may so happen that even if it is not a fault condition, since they are not habituated to these practices, the release setting may not work. So again, we are revisiting this practice of protection. And another feature is, let's say, what was happening earlier, we did not have this self-healing nature of the grid. Is anyone aware what is this self-healing feature of our grid? Okay, I'd like you all to look upon this self-healing nature of the grid. So basically, the objective of the smart protection, it is to provide reliable power to the customers at all times. Then moving on, okay, what we have got here is the architecture of smart grid. So we can see here there are 7 major domains, starting from our generation, transmission, distribution, customer, then service provider, operations, and markets. So I think generation we have talked in elaborately about this. So can anyone just sum it up for me? What is this bulk generation domain? Anyone? Hmm? Yeah, and also like whatever we are getting now, like large scale wind power plants and all these generating resources, they are coming under bulk generation. So this domain you can see it is communicating with three other domains, that is transmission. Obviously, that is clear. You are generating some power means you need to transfer it to the load. That's why it is communicating with the transmission domain. And for the operation domain, the operation domain will communicate with all other domain because it is like a controller who is looking after the operation of the whole grid. So this amount of energy that the generators want to inject, so that is also being calculated by the operations, and that will be again told to the generation system. Then we have this markets, so we'll talk about the markets in detail in a few minutes. So coming to transmission again, so we talked this, so this transmission system, it will take power from generation and give it to the distribution system through this transmission domain consisting of our towers and transformers and lines. And again, this will communicate with the operation systems for their monitoring if the power flow is within the limit or not. So I have a question that the operations, they are monitoring the health of the transmission lines. So again, which features of this line is being monitored by the operation system? Like what do they check for power lines to be healthy or in optimal condition, you can say. We can see that the transmission domain, it is interacting with the operations domain. So operation, it is through communication line. So what is this operation domains monitoring in the transmission system? Power flow, power flow, not power scheduling. Power scheduling, during that power flow, you'll have them in the lines. So we have some limits of power flow, power lines, right? Okay. So what will happen is we need to monitor. Let's say we have a cheap generating station and we have a heavily loaded distribution system. So what will happen is we will try to get the generation from the cheapest source and provide it to the load. So the link between the cheapest generating station and the load, so that will be heavily loaded because we'll try to extract power, highest amount of power that is possible from the cheapest source because we want power at lower cost. So what that will lead to overloading of this line which is connecting this cheapest source to the distribution system. So this is what we are looking about. So this is the transmission constraint that we are having, that even if you have a source which is capable of, let's say, 100 megawatt generating 100 megawatt of power, but if you have a line which is able to carry only 50 megawatt of power, then even if you have generation, you have lost this cheap generation due to the inability in the transmission system. So if let's say a line is always being overloaded, it will give an indication to the operating system to install new lines in that system so that power can be transferred from these generators to the distributions. So I hope this is clear. Then moving on, we have distribution system. So obviously the transmitting power at higher voltages. Now we will step it down at the distribution substation level, and then we have from the distribution we'll give it to the customers or the end users. So coming to this markets, so are you all aware of this market domain? Anyone? Do we have a energy market in India where energy is being traded? Okay, I'll throw some light here. Basically, yes, we do have similar to, you can, all of you must have heard about like currency or that stock market in Bombay. Similarly, we have an energy market in India, that is the IEX. You can search that site even. So what happens is here you trade the power, and basically here comes the role of service provider. So this service providers, they do not have any generating stations. What they do is they will buy the power from the generating stations and act as like as a middleman and provide it to the customers. This trading of power we have at in our power market. So basically, we all know that our power system, it is operating in 15 minutes time interval. Are you all aware about it? The time block of operation. So basically, the 24 hours we have in a day, it is divided into 15-minute time slots, and at before this 15 minutes, the power is traded here to meet the demand is this 15-minute time slot. So you may read about it. This is, and as you have talked about operation, so this domain is communicating with all other domains and service provider. As I said, this is like a middleman or is like a player in the market who is maybe buying energy at cheaper sources and giving it back to the customers so that it will have some profit. So because we have time varying prices in the markets, so it means whenever it is sensing that the prices of power are low, it will buy in bulk and then sell the power to the customers at a higher rate so that it will gain the profit. So is this architecture clear, or if you want we may discuss about any domain which you are not clear about? Anyone? Yeah, sure. Yeah, sure. I'll do it. So any of the domains which you want to discuss and okay, so yeah, okay. So let's talk about transmission. So I think in the authorities of India, we talked about two transmission utilities. Do you remember that? Lot of state entities. So they their role have actually evolved through the years. So PGCIL now it is only what its duty is about. It will take care of the infrastructure, the grid structure. It does not have the control over the power that will flow through the lines. That will be decided by the dispatch centers or operation domain, we can say. And this transmission and uh, we have one authority. So another question is also there, if is open to all. Maybe in the generating stations we have more than one player. We know there are like NTPC, we have NHPC, we have NEPCO, we have other private players also. They are coming now. Coming now, private players are actually abundant. The state generators or the government generators that they are going down. So this bulk generation is having many players. And this distribution also, we know each distribution state distribution system, it is having a separate discom, distribution company. But the transmission system, we have a single entity, that is the central transmission utility. So it will give the open access to all the users who want to use it, because to interact like the power from generation to the distribution, it has to go through the transmission domain only. So if any open access is not given to them, so it may lead that power is available but it is not able to flow to the customer due to the unavailability of the transmission domain. So it will give, we can say, it will not discriminate, non-discriminatory access to the users, and it will collect tariff for using its transmission lines. So currently, this central transmission utility PGCIL, it is a government authority. Moving on to distribution, we know previously it was with the government, but now rapidly this distribution system, they are going to the hands of private companies. Uh, we know as we know Tata Power, it is growing, and major cities and states like Delhi also, where this is going into the hand of private companies. And in the future also, like for the transmission, we have the transmission system operator, and its role are actually defined in our uh, for the electrical grid by the electricity authorities. But for the distribution system, the role is evolving, because earlier we did not have these generating resources. Now since we have this upcoming resources in the distribution system, so reforms and policies are actually emerging, and currently we don't have a distribution system operator in India, but we are deciding on what should be the role. What, because it is now having the power of many clean energy resources, so it may lead to their misutilization. So it is now in the talk that what should be the roles, what would be the policies governing these bodies, and what exactly should be this distribution system operator. So I can assure you that we don't have a DSO here in India, but its role is emerging. Okay. Okay, I think we'll move, or if anyone else has any other. Okay, I'll move to the next line. So these are the various IEEE standards we had. So why do we need these standards? Can anyone just tell me? Yeah, yeah, correct. So basically we need standards to maintain the uniformity. So we have different standards for interconnection of these distributed energy resources, and we have this distribution energy resources. If they want to connect to the grid, they have to follow certain standards, and that is governed by the IEEE 1547 standards. And then we have different type of standards which you may have gone through in depth. These are just policies, and I'm not going into depth of that. Then we'll move to the question and answer sessions. Okay, so the first question, it is open to all. So I'd like everyone to participate. So I hope this is visible to everyone. The first question, the typical voltage level of the primary customer is. Any answers in the chat box or by meeting? I'd like everyone to participate, please. Okay, I'll take 11 kV from you and others. Okay, Banu Prasad is saying 11 kV. And anyone else? You can type in the chat box, it's fine. Lakshmi, Riya, Shrish, Nagesh. Okay, then can you give me some examples of primary customer? Okay, I'm getting 11 kV's answer. So an example. 400 kV, 400 volts, not kVs. Hmm. Huh, so who will be these? Like for 400 volts, they are users like us. Yes, some small scale industry users which require power. So yes, you all are correct. So first one is the correct answer is 11 kV. They are the primary users. So let me highlight this for you. Then the next question is open. So which of the following is not the characteristic of the existing grid? Manual monitoring, failures and blackouts, self-healing, one-way communication. Okay. Okay, self-healing. Please, can anyone enlighten us what is self-healing? Anyone? Okay, which components are helping this self-healing? Through what components? And from like what we have to heal? First of all, what is that injury? What is that error? Does anyone know about reconfiguration or automatic reclosures? Hmm. Transient fault. And okay. And what about this feeder reconfiguration through sectionalizing switches? Switches, anyone know about switches in distribution system? We have tie switches, we have sectionalizing switches. Anyone? Okay. No, no, breakers are different. I am talking about switches, sectionalizing switches. Huh. So what, like how they are self-healing? So coming on, we know that our distribution system, it is radial, while our transmission is meshed connection. Radial means we have like one source and the loads are in one direction, and so that is what is radial or weakly meshed. So what happens is, let's say we have a fault in this section of the grid. Okay, but what will happen is, if we open the breakers, then sure, sure, sure. I'll explain it here. Thanks. Okay. See, so this is the typical structure of a distribution system, and we have loads at each bus. Okay, at everywhere we will have loads. Okay, and we have some sectionalizing switches in between. Okay, so in normal conditions, these will be normally open switches. Fine. So let's say we have a fault at this end, and we had a breaker here, or let's say, we had a breaker in this position. Okay, so what will happen when this fault occurs? This breaker, it will open this circuit, right? Okay, so what will happen is, due to this fault, the loads which we had here at this bus, these are healthy parts, right? But since the breaker is here, we'll open it, so this load which was healthy, it is also getting switched off. Is it clear? Okay, so what will happen in this condition, if this switch, sectionalizing switch, it will convert into closed condition, so that the power, it can flow from here to here, and this part is already opened by the tie switches, so that we are isolating this fault, and the healthy load which is here, it is getting supplied through this path. So is this part clear? Hello? So this is what we call as reconfiguration. So in earlier part this will be open, but when we have a fault, to isolate the faulty section and restore power to the healthy part as soon as possible, we do this. Okay, so I think we have this answer. I'll just check the chat box one. What answers we had for this? Okay, self-healing, recovering from failure. Okay, so we'll go with self-healing, I guess. So it is correct. Okay, then moving on, we have our next question. So, which of the following may not be a barrier in smart grid technologies? Lack of infrastructure, lack of financial resources, lack of a regulatory framework, integration of grid with very small renewable generation. Hello, am I there? Uh, Beware, which of the following is not a barrier? Any other answers? We are getting option D, but I like everyone to participate. Few more answers. So why can anyone just say why it is not a barrier? Or maybe other way, why others have a barrier? Okay, and what advantage it will have except cost? A very small scale renewable means it will be, I guess, green sources. Am I correct? So again, it will help us in our objective of reducing emission. So if you remember of the objectives of smart management, so one of them was to reduce our emissions. What about lack of infrastructure? Which components, which infrastructure, which we do not have in this smart grid technologies? Let's talk about the Indian grid. As you spoke about smart meters, do you think our grid is right now equipped with very smart meters? With you, with us? Yeah, so we are very far behind. We don't have these smart meters at our home right now. And this also we need lot of converter technologies for this HVDCs, which is also in a very early stage. So this will come under lack of infrastructure. And what about lack of regulatory framework? I think we just discussed it for someone's doubt. I think we're discussing something about distribution system operators. Yeah, so that framework, that policies, they are coming up now, and maybe soon we'll have a very fair policies and transparent rules and regulation for these new bodies or new entities that are coming up in our electrical grid. So the DSO is one of them. So I think we'll go with option D for this one. Okay, time synchronization. We have another question here. So according to the IRIGB, time synchronization accuracy requirement is up to zero point 0.5 microsecond, 1 microsecond, 2 microsecond, or zero point 0.1 microsecond. Any answers, please? Okay, I'll explain. Anyone else? Okay, I think I need to explain this. Or does anyone have any idea? Okay, I'll explain this. So basically, as we talked, we have many sensors, or we can say many PMUs, which are sensing, let's say, voltage, current, frequency at each and every time instant. So what is happening is, let's say we have a huge network here, and we have, let's say, these are all sensors. Okay, from where we are collecting data. So let's say we are getting some voltages V1, V2, V3, V4, and let's say this is some sensor S1 and this is sensor S2. I'll take two sensors right now, and we know, let this, according to this sensor 1, this V1 was at, let's say, time instant 1, T1, T2, T3, and T4. And let's say this S2 sensor, what it is telling, that it is getting this V1 or some other measurement, but at say a time instant T1 dash, which is different from T1, T2 dash, T3 dash, and T4 dash. So for the same set of data, we are having two different times. So why this will happen? This error may happen if we don't synchronize our clocks. Like it is now 1932 for me, but if someone has set it, his or her own clock 5 minutes ahead, so the time it may show different. So it is the same time for us because we are synchronized with the Indian Standard Time, right? IST. But similarly, you can see that for these sensors, we have a global clock, and according to this clock, so let's say this clock is at t equal to t1, at certain instant. Huh? No, we are coming to that. We are not at that actually. What I'm telling, we will move to that. I'm just telling that, let's say we have to timestamp this data, right? So if this global clock is saying that this V1 data is, let's say, t equal to 5, so all these sensors have to timestamp their clocks and they have to position this as 5 so that we get uniform data, and this difference we don't get. Otherwise it will be confusing in the studies, right? For this V1, if someone says it was at time t1 and someone says it is at time t1 dash, we will not know the exact timestamp of this data, which will be confusing for our studies. So we have this global clock, and these all sensors, they synchronize their internal clocks with this global clock, and this time synchronization accuracy is, we have set to 1 microsecond, and this is the standard. Okay, 1 microsecond, which you have said, that means we have to be accurate up to time 1 microsecond. So if it is, let's say, 1 millisecond, then we are decreasing the accuracy, right? And if you want a data which is, let's say, accurate by zero point 0.1 microsecond, so obviously this will be more higher accuracy. The accuracy will be very high, but the cost, the effort that will be utilized for this high resolution data, that will be greater. So this is basically, this is a trade-off between what you want, at between the cost and the accuracy. So according to this standard, what we want is the synchronization accuracy. This should be up to 1 microsecond. So is this clear? So these are the standards. There are various communication protocols are also there, so you can study them. I think it will be in your slides. So if you go through them, they will tell you in detail what should be this time accuracy, and according to this IRIGB standard, it should be 1 microsecond. Okay, okay. Now coming up, next question. The boundaries of customer domain typically consider which type of meters? Okay, I'll ask others. Any other replies? Boundaries of customer domain. Okay, we got another ESI, Energy Services Interface. Okay, I think we'll go with this, and I think most of you won't have any doubt in this. It is quite evident that this is ESI. Then we have the question next is, transmission network is typically operated by load dispatch centers, distribution company, regional load dispatch center, generation company. Okay, can anyone elaborate me the duties or roles of this regional load dispatch center? Generation one? And what generation? I was not clear what the point you're talking about generation. Generators? Huh. Hmm. Hmm. Substations are different and power plants are different. So let's go with power plant. True, true, true. And we have interstate generating station also. Hmm. Mm-hmm. Okay. Can you tell me hierarchy of this load dispatch centers? Okay, national. Do we have a specific name this for National Load Dispatch Center? It is at Delhi, but do we have it a name for it, the organization? It is the National Load Dispatch Center. I agree, but there's also a name. It's a company like, yeah, it is starting from G. Recently changed its name. Yeah, yeah, very recently it has changed its name. Previously it was PUSOCO, Power System Operation and Control, I think, Corporation, and recently it has changed its name to Grid Controller of India. So that is at the topmost hierarchy, National Load Dispatch Center. Then we have five regional load dispatch centers, as Mr. Anup was saying. So for the five regions, who will take care of the SLDCs under them and also intrastate generating stations. And then at the state level, we have the state load dispatch centers. So, are you aware that how in the day ahead the load dispatch processes take place? Can you just, are you aware how this dispatch processes take place in the day ahead? Sure, sure, you can go ahead. Hmm. Okay, okay. And that is true, that is true. What I'm asking is, let's say today, let's say now it is 7:42. So we all are at the receiving end. So who is deciding that the power that I'm getting, that is from a generator from my state? Let's say I'm in Roorkee. Let's say it is from coming from Tehri Dam power system, or it is coming from Delhi. So who is deciding the power or how? Hmm. Hmm. So they will come up with a plan, no? So what they do is how much I'm aware of, I'll just try to explain it to you. So what happens is in the day ahead, what will happen? Like today, let's say they will plan for tomorrow. Okay, they will have the forecasted. demand that is going to come for the entire nation. So in the first step, what will happen is, let's say my government is the Uttarakhand government. It has forecasted that tomorrow at let's say we have before that, I'd like to aware you that we have this plan for 15 minutes. For each 15-minute time interval, we have our plans laid out. So let's say our Uttarakhand government for tomorrow, it is anticipating that let's say from 12 to 12:15, the power that is the demand is about to, let's say, 50 megawatt. So then what it will do, it will see which all generators Uttarakhand government is having. So SLDC basically, it will see how many generators it, okay, I'll just admit someone. So the SLDC will see if it can meet the 50 megawatt of load according to the generators it is owning. Let's say Uttarakhand government comes to know that it has only 20 megawatt of power which it can provide it to the customers. That means it is 30 megawatt deficit. So it will pass on this information to the RLDC. Uttarakhand is in the northern region, so the northern region RLDC we see. So all the northern region states SLDCs, they will give this information to the RLDC of the northern region, and similarly for the other four RLDCs, they will get the like the need of the states, whether they are in deficit or they are in surplus. And when it will have that area information of that deficit or what we say extra surplus, it will try to balance within the region only. What you told was for inter-region RLDC, that was also correct. But what will happen first is, what first they will try to balance it in the states. If they are unable, they will move it forward to the regions. The RLDC will again balance the power in its region. And again, if let's say RLDCs are also deficit or a surplus, they will pass on to the NLDC, and NLDC will have the need for the whole nation, and accordingly it will balance all the RLDCs. And this process, again, it will go back to the RL, it will communicate the NLDC, it will communicate that if you want this much amount of power, let's say 10 megawatt, you will be taking this from the other, let's say northern will taking from western, and this information will flow back, and the chart or the prep the plan for the next day will be prepared in this way for the whole nation. And obviously, again, we'll have imbalance. Let's say they had anticipated 50 megawatt of load, but it can again go ahead plus minus 40 megawatt, or it can go up to 60 megawatt. So this imbalance, again, it is also being carried in the intraday. So this is first in the day ahead. Then again in the intraday also we have, let's say, these markets. So where this power are traded to mismatch to match this imbalance in the loads. So I hope. It is done. It is done in the regular basis. If you have time, you may go ahead. So this is the process that happens. The hierarchy I told. First, SLDC will communicate to ILDC, and they have even time, like from morning like 6 to 10, SLDCs must have communicated their data for next day to the RLDCs, and within like 10 o'clock today, everything will be finalized for tomorrow. Tomorrow means 12 o'clock, for 12 o'clock midnight. So by night 10 p.m., everything will be finalized for the day ahead. But again, changes in the day ahead will also happen, plus minus something. And that mismatch will be balanced in the real time through the real time power markets that we are talking about in the market domain. So these all monitoring, and in the real time, that is again the operation domain, that is the POSOCO. It is monitoring in real time the status of the grid. And we have this AGC also. We have a new, that is again a whole lot of discussion. We have a new plan. Huh? La, there are. Wha- Huh? True, true. But again, we are just forecasting it. At the real time, anything may happen. Am I correct? Huh. Reserve, we are also required to have some reserve mandatorily, spinning reserve, what we call. So this plan is also made economic dispatch, which we have also some reserve, which the generators get payment for keeping this reserve to support the grid in unfavorable situations. So because they are holding up that power for the grid, they are also getting paid for this, sir. So you can visit the site of Posoko, or in the next, I can give you the site. You can see they have very transparent charts. They have very transparent data there where you can see how the prices were there in a day, how much peak demand they met, and all these are very transparent platforms, and you can go and see there if you want to explore more. Grid control of India, you can go there and they will have that. And from markets you have Indian Energy Exchange, IEX. So every data is available there. Okay. Okay, I think lots of discussion. So yes, I will go with regional load dispatch center here. Okay, the next question. So the service provider domain, it will communicate with which domain? Okay, for others, I would like to hear from them. Any other answers? Any other answers, please? Any other answers, please? Service provider domain. So actually, service provider domain will not interact with the distribution domain. It will be interacting with customer domain, and other than that, it will also interact with the market domain and service provider. Sorry, operations domain. Okay. So basically, what the service provider it will do, it will in the market, basically it will buy some power from some generating stations and it will give it back to the customers. So that way it is for customer. Then we have ESI. So energy service interface, I think this had come up in some other question. Communicates with other domain via which mode of communication? Sorry, AMI. Okay. Thank you for your response. Any other response? Okay, I am just waiting if I get any other response. Okay, another AMI we get. Okay, couple of other answers. Okay, so yes, all of you are correct. Then we have a question on standards. So for the interconnecting of these distributed resources, so which standard do we have? Okay, any other response? This is factual question. So these distributed resources which will connect it basically in the distribution system because they will be in the customer platform only. So they also have to meet certain standards so that they get connected to the grid. Okay, we got another as A. Okay, B, A, B. Actually, we need to highlight that this is for distribution networks, second to distribution networks. So actually, this will be D. These standards are also readily available in the IEEE sites. So just a second, what happened? So the correct answer is actually IEEE standard 1547.6. Then moving on for I think the last question. In which of the following methods data and power can be transferred with the same conductor? Power line communication. Thank you. Okay, cognitive radio. Any other answers? Okay, can you like cognitive radio is wired or wireless transfer? Okay, and can you just then explain how power can flow in a wireless network? I know, so communication of data, but what we meant is power, real power flow. Yes, sir. So it will be power line communication where both are true, true. The data will be communicated through cognitive radio. It will be power line communication. But the advantage here, what will is having that we don't have to go for extra infrastructure. The same conductor which is carrying power that will also use to carry or the transfer the data. Hmm. True, true. But the question what is placed here, it is for transfer of both data and power. So here we'll go with power line communication. Okay, I think we are at the end of the session. So I'll be happy if we have any doubts. Okay. Yeah, yeah, it will be available in the Google Drive. I think they will share with you the link. There you can access these PPTs for today. Okay. These recordings will also be available in the YouTube channel, so you can also access there. Thank you so much. True. Okay. For week 1, I think these were all the you got to know about the theoretical aspects of the smart grid. So I don't think week 1 will have any numerical questions. Assignments, certainly, I think you have some assignments and you have some deadlines which you have to fulfill for the courses. But those I am not responsible for the assignments, so I have no idea what questions have been framed. But I can assure that they won't be numerical because whatever you have studied in this week, it is all theoretical and standards and all these things. So thank you. Okay, any other queries? Actually, today I also got some microphone issues in the first 15 minutes. So I'm extremely sorry and I'll take care for the next. So this was also my first time, so it was very nice interacting with all of you. And basically, I was happy that it was two-way communication. So maybe it was a smart communication between us. So I'll be happy if this is how the course will flow through. And I may not always be able to answer your queries. I'm also in the process of learning. So, but I'll definitely try to clear all your queries. If not in the real time, next in the next week, if I'm not unable, I'll try to cover and clear your queries. Thank you. Thank you, Mr. Shri Shashidhar. So it was nice that you also took part. So it was always two-way. And in the future also, I like all of you to speak. And so that I'll also, that I'll also learn from you. And okay. My PhD is in power systems engineering, and I am basically focused on developing optimization. Like, you must be aware there are two ways, that is control algorithms and optimization. So I work on the optimized system operations. Like, my work is very much in line with the objectives of Grid Controller of India. So basically, as I said, this distribution system, its role has changed. So my work, it is on this transmission system and distribution system, their coordination, their cooperation, and how to optimally use these resources so that we have optimal uses of these resources in our grid and optimal operation of the grid. Okay, thank you so much. Okay, yeah, sure. I'll share the LinkedIn maybe next time, and email ID, I'll just maybe type it here in the doubts one. So I think this is visible. This is my email ID where you can contact me. And for LinkedIn, if you want, I'll share in the next session, surely the link. Okay. So I hope next week, week two, you'll all watch the video lectures, and again we'll summarize and discuss about week two and go through the questions. So sure. So I think we'll close the session if anyone has no any doubts or something. Okay, thank you everyone. Have a good night. Thank you so much.